Chapter 7 is the place to be now in your digital ALEKS textbook. And here we will learn about the basics of rational functions. Rational functions are not functions that are crazy. They are functions that are comprised of two polynomials built into a quotient. Now, while the first definition sounds a lot more fun, we are stuck with the second definition, so we have to go with it. Rational functions look messy, but what we've learned to do with polynomials, like adding them, subtracting them, multiplying, factoring, and dividing, will help us handle our rational functions. They really look worse than they are once you learn not to be intimidated by them. So, for example, we're asked to find the domain of this big mess. Now, remember, the domain is the set of all values of x that you are allowed to plug into this. So all you have to think about is, for this nasty mess of a function, the domain is all values of x that don't make the function go kablooey, right? So what values of x are we allowed to plug into this? Well, the best way to do it is to start by saying all real numbers except, and then find the ones that you can't use. Now, the numerator right here doesn't have anything to do with the domain. We can plug in anything we want into x in the numerator. If left alone, we could plug in any number for x that we wanted to in the denominator if it was floating around by itself. However, it's a denominator, and we all know that we're never allowed to divide by 0. And so the domain of this particular function is called all real numbers, all reals. We can plug in everything except values of x that would make that denominator turn into 0. Now, how can we figure out where that function that's in the denominator gives us 0? Well, that's what we just saw in the last unit, where we learned how to factor and solve equations. So this polynomial here will factor, I hope. We need x's as the leading terms in the factored pieces, and then we need constants for the trailing terms that multiply to negative 15, but then added together as the coefficient of x will give us the plus 2. So all the different pairs of numbers that multiply to 15, 15 and 1 or 1 and 15, that combination is never going to give us a 2. 5 and 3, 3 and 5. Okay, now we're on to something. How can we generate a negative 15 as a product of a 3 and 5 with either a positive or negative, but then added together, those numbers will produce a positive 2? Well, that's going to look like this. So again, the 5 times the negative 3, that's what produces the negative 15. And the cross terms of the multiplication, 5x on the inside and negative 3x on the outside, that's what gives us the plus 2x. So the domain of this mess is all real numbers except the ones that make the denominator equal to 0, which is all real numbers except the numbers that make this version of the denominator equal to 0. And that means we cannot use 3 or negative 5. So the domain of this function is all real numbers except 3 and negative 5. I guess I should write them in numerical order. So all real numbers except negative 5 and 3. Now here's another mess of a function. But again, we're thinking about domain. We're thinking about all the numbers that we are allowed to plug into this. Now, the numerator, no problem with any number at all. The denominator, no problem with any number at all, except a number that might make x squared plus 9 equal to 0. Let's think real hard, and there aren't any. There are no numbers that will plug in for x and produce 0 in this expression x squared plus 9. So x squared plus 9 is never 0 ever, ever, until we start studying complex numbers, which we're not going to do here. All right, so we can plug in anything we want in the numerator. We can plug in anything we want in the denominator and never produce a 0. And so the domain here is all real numbers. everything is allowed to be plugged in.